Okay, we have some identities to prove, and they have squared trig functions in them, which is good news, because we know loads of identities with squared trig functions. So in core 2, you had the one with sine squared x and cos squared x. Now I've got other ones involving these things. Okay, so I'm going to do the normal strategy. I mean, I could start with the left-hand side or the right-hand side. There's nothing really to choose between them. So let's start with the left-hand side. Okay, could just as easily have started with the right-hand side in this particular case. Okay, now let's remember the trig identities I know. Okay, so you do have to learn these. So we know that sine squared x plus cos squared x equals 1. Well, I don't think I'm going to be using that one, but I'm going to be using the other two. If you remember, if you divide this one through by cos squared x, you get tan squared x plus 1 equals cos squared of x. 1 over cos squared of x, which is sec squared of x. Okay, and if I divide this one through, the top one through by sine squared of x, you get 1 plus cot squared of x equals cosec squared of x. So I've got sec squared x here, I've got cosec squared x here, so I can actually just substitute in for cosec squared of x here. For cosec squared of x, I can have a bracket with 1 plus cot squared of x in it. Okay, and then I take away another bracket which has sec squared of x, which is tan squared of x plus 1. Okay, and this is going to drop out to the answer very quickly. Of course, this is just a test in have you learned your identities. If you can't get these identities, okay, then you're going to make no impression on the question. But if you know them, it should be easy. So, first bracket, the brackets aren't doing anything to that. Second bracket I'm taking away, so I get a minus tan squared x, but I get here a minus 1. And 1 take away minus 1, of course, is 0. So this is cot squared of x minus tan squared of x, which does equal the right-hand side. But remember, we need to state a conclusion. So what we'll do will be LHS equals RHS. We're saying we have done the proof. Okay, so when we look at part B, once again, we've got some squared trig functions. Okay, now, when you've got one side that is, in a sense, more complicated than the other, then that's the side you should start with. So this has got an extra level of complexity because there's squared brackets going on. So that's the side we start with. It's more easy to see ways of simplifying something that's already complicated than seeing the correct way of simplifying something that's already simplicated. Okay, if that makes sense. So we've got to square out this bracket. So remember, we don't just square this and square this. We do it properly. This is cot x minus 1 times another bracket of cot x minus 1. So do a grid if you want to. Cot x minus 1, cot x minus 1, cot squared x here. Okay, terms here. So it's going to be cot squared x. Cot squared x. Okay, it's going to be minus 2 cot x plus 1. That's what you'll get from the grid if you do it properly. So this is the left-hand side. So let's make it clear that's what I'm working with. Okay, so I can see, I can see a minus 2 cot x, which is supposed to appear in the answer. Okay, so let's actually put that on its own. So I've got a cot squared, this should be a cot squared x. Okay, I've got a plus 1, and then I've got minus 2 cot x, which I can already just put on its own at the end because that's where it is in the answer. So I could put brackets around this bit. So if only it were true that cot squared x plus 1 was the same thing as cosec squared x. But that is exactly the identity we used in the previous example, okay, an identity that you have to have learned. So once again, apart from squaring out a bracket, this is just an exercise in, do you recognize that you can turn that into cosec squared x? Have you learned these identities? So that bit doesn't change, so this equals the right-hand side. So I haven't cheated, so the left-hand side equals the right-hand side. I write that down, and I've proved that identity.